Watch what happens when a single bird dropping lands on industrial steel. The waste produced by pigeons and gulls is highly concentrated uric acid. With a pH level between 3 and 4.5, it acts as a slow-motion solvent, eating through vehicle paint, commercial roofing membranes, and solid concrete. This chemical damage is only the beginning. Pigeons use their own dried guano to build flat plateaus, creating a foundation for new nests. One nest attracts 10 more, packing hundreds of birds into tight structural corridors. Relocating these birds rarely works. Pigeons have an internal biological GPS tied to site fidelity. They lock on to the specific pheromone scent of their established colony and fly straight back to the same ledge. That single bird on a warehouse rafter acts as the permanent anchor for an exponentially growing, highly corrosive biological colony. At the macro scale, the threat becomes a matter of mass and gravity. Large accumulations of dried guano act like a sponge. When rain hits a flat commercial roof covered in bird waste, the guano saturates. This creates tons of biological deadweight, often leading to complete structural collapses on industrial hangars and warehouses. On public infrastructure, guano piles up on steel gusset plates. This accelerates oxidation and rusting, compromising the critical joints that hold a bridge together. Inside the building, the threat shifts to the air. When dried guano is disturbed, it fractures into a fine airborne dust. That dust often carries Histoplasma capsulatum. Breathing in these fungal spores causes histoplasmosis, a severe respiratory infection. Commercial HVAC systems pull these spores through roof intakes and circulate them across the factory floor. Left untreated, bird infestations compound into massive structural liabilities and severe occupational health crises for everyone inside. In the open sky, the problem changes from slow corrosion to immediate kinetic impact. Large flocking birds pose a severe physical threat to commercial aviation. The danger comes down to basic physics. A 12-pound goose hitting an aircraft at 150 miles per hour generates the kinetic energy of a 1,000-pound weight dropped 10 feet. That localized energy transfer shatters titanium turbine blades instantly, destroying an engine from the inside out. This is the forensic reality of Flight 1549. A single flock of geese can cause dual engine failure and force an immediate water landing. For airport authorities, bird control is a strict life or death mandate designed to prevent these catastrophic kinetic energy transfers. Industrial sites rarely use lethal culling to stop this damage, even with the threat of collapsed roofs or engine failures. Businesses are restricted by the Migratory Bird Treaty Act, a federal law protecting almost all native birds from being hunted, captured, or killed. Clearing out a nest with active eggs or poisoning a flock triggers severe federal penalties. Companies face massive fines, and executives can face prosecution for lethal intervention. At the same time, birds are highly intelligent. If using basic scare tactics like plastic owls or noise cannons, flocks recognize there's no physical threat and habituate within 48 hours. Modern industry is caught in a paradox, under siege by a destructive biological force, yet federal law mandates a strictly non-lethal defense. To bypass this legal trap, engineers use Integrated Avian Management, or IAM. This is a tiered strategy combining deep sanitation, physical exclusion, and behavioral harassment. Phase 1 requires a forensic decontamination of the site. Crews wear full hazmat Tyvek suits and P100 respirators, specialized masks that filter out 99.9. Phase 2 builds the physical armor. Installers string heavy-duty architectural netting across open rafters and loading docks, creating an absolute barrier that seals off overhead vulnerabilities. For exposed ledges, they install physical deterrents. Dense arrays of stainless steel rods and low-profile 5,000-volt electric tracks make landing physically impossible without harming the birds. True defense requires wiping out a building's biological footprint and wrapping it in a permanent hostile exterior layer. Physical netting has limits. You cannot wrap a 500-acre solar array or an international airport in polyethylene twine. For massive open-air sites, the shield must be automated. Facilities deploy autonomic laser systems. These units constantly sweep brilliant green geometric patterns over flat spaces. Birds perceive the approaching light as a physical predator, triggering an intense flight response. Above the runway, airports use military-grade avian radar. These tracking systems monitor flock density in real time, allowing air traffic controllers to pause takeoffs before a kinetic strike occurs. Even ancient biology is integrated into the grid. Handlers deploy trained birds of prey and robotic drone hawks to actively patrol and clear the sky over sensitive zones. Maintaining this shield requires a specialized intersection of hazmat remediation, structural engineering, and behavioral warfare, all working to protect human infrastructure.